Good morning. Welcome to SOS Webinar. Today's topic is how to simply and efficiently make a power supply design with linear technology. Today's presenter is going to be Tomasz and Joachim from Linear Technology. And this webinar will take about an hour and a half. Also, whole webinar will be recorded, so you can find this record at our webpage in about a week. At the beginning, I would like to say some organization issue. First of all, I would like to ask you if you have any question regarding the WebEx, please contact me. I will be your admin today, and my name is Mima. And if you have any question regarding the presentation, please write this question to Q&A window, and all these questions will be answered by Tomasz at the end of his presentation. Also, I would like to remind or ask you if at the end of this webinar there will be a short survey regarding your feedback about this webinar, about topic, and so we would like to ask you to fulfill this webinar and provide us with your feedback, and one of you will be drawn by a lot and can win demo board of micro module from Linear Technology. So now I would like to pass the word to Tomasz to start his presentation. Good morning, Tomasz. Can we hear each other?
Good morning, Miriama. Yes, we can hear each other. Good morning to everybody.
Okay, so now you can start your presentation.
Thank you very much. I have the presenter right, so let's see. Should appear in a moment. Let me share my desktop with you.
Okay, now we should see the presentation. Yes, now the presentation is on the screen, so you can start.
Thank you very much. So, ladies and gentlemen, welcome to the Linear Technology DC-DC Micro Module Power Products webinar. We are in Bratislava together with my colleague Joachim, a field application engineer in Slovakia and Poland. My name is Tomasz Kubasi. I represent the Linear Technology offering in 3 countries of Eastern Europe. This means Slovakia, Czech Republic, and Poland. And I will have a pleasure to read today's presentation. As the title of the presentation suggests, we will be speaking about micro-module product family. But first, in order to show you how micro-module offering goes together with linear technology approach to the market, I would like to show you a couple of slides of the company. Today, analog is about 17% of the $250 billion integrated circuit market. We have listed a number of the largest suppliers in both the analog space and the digital space on this slide. As shown on the graph, there are more companies that focus on digital products, and most of them use similar processes in production. The analog market has fewer suppliers and typically requires more specialized processes. The analog market can be further divided into the higher end, also the commodity and second source products. We are focusing on the higher end, and we provide solutions that include more features and more value to the customer's products. Some milestones in the company's history include the start of the company in 1981. 5 years later, we went public. We achieved $1 billion in sales in 2005, and 3 years ago we celebrated our 30th anniversary with record sales of nearly $1.5 billion. The value we deliver to our customers is not only innovative high-performance products, but also outstanding support throughout their product life cycle. We provide solutions that offer outstanding performance and price trade-off. And we provide the best technical support worldwide. I hope some of you know us from this perspective and could already experience it. We can provide industry-leading quality and reliability, which allows us to support the most demanding applications in the area of automotive, industrial, and military and space markets. I'm not sure if you know, but the Curiosity rover on Mars contains more than 200 linear technology products. So linear technology has a very broad product mix, allowing us to support many applications and markets. Over 50% of our business is power conversion and includes families of linear and switching regulators, of monolithics and controllers. In addition, we have micro-module regulators that provide extremely small, complete power supply solutions by including the inductors and almost all of the external components required in a small package. Approximately 20% of our business comes from our signal conditioning products, which include precision op-amps that we started with several years ago, and references, as well as lithium-ion battery monitoring products and high-performance RF mixers and modulators. The rest of the business comes from a wide range of products that include data converters, interface, and timing products. One of the objectives of this WebEx meeting is to show that we in linear technology support you in every stage of your product life, starting from the concept and design phase by delivering innovative products, as well as taking care of the design process itself through mass production stage with uninterrupted deliveries and availability of our products, which, once mounted into it, do not risk a quality issue. This is all for one reason. That you become successful with your product. That's easy. Let's have a closer look at the very beginning when the idea comes to your mind. Complexity of the design has direct impact on time consumed for delivering a working prototype. It would be great that, especially in some areas, you just put an integrated solution and it starts working. Power supply is always needed at every design. Wouldn't it be great if you could fix it in one afternoon? We can put our efforts in another key competency, assuming our power supply is an easy step. This is exactly the idea behind a micro-module approach. It allows you to allocate less engineering time to power. Once running a mass production, you want stable delivery. We keep our production process in our hands. This means it is reliable and we can keep it very productive. We use wafer hubs in the US to deliver ready wafers with semiconductor dies, which we place on a shelf, which is called a die bank. Normally, the process of manufacturing the wafer takes 8 to 10 weeks. In addition, after we produce the wafer, it needs 4 weeks for assembly and testing, and normally you need 12 to 14 weeks for ready product. Because of the die bank, which is in between the assembly and the production of the wafer, we can shorten our lead time in 4 to 6 weeks, because when the demand comes from the market, we just take the ready wafer, assemble it, test it, and it's ready for the customers in 4 to 6 weeks. In order to keep delivery stable, we put special care on risk management in our production. We keep a stock of raw materials for next 3 to 6 months. Our factories are mirrors. This means that one can take over production of the other one easily. We also subcontract our assembly in approximately 20% of cases. And we have also equipment buffer, which is staying in a corner, waiting for increased production volume. The whole testing is time-consuming in production process, but we take it extremely seriously, and this is why we are able to deliver highest quality products on the market. We qualify products based on automotive standards, and this is why with our 0.09 fit rate, fit means failure in time, we can guarantee the quality of our products throughout the lifetime. In terms of testing, between wafer up and die bank, wafers are tested at room temperature. Between the die bank and assembly, we run second optical screen at testing. We do it for 100% parts in the room temperature. But these parts, which are rated differently, it's here in this column. This means commercial, E means extended, industrial, and so on. We test our products in the cold and hot chamber. This means that we can guarantee how the product behaves while inserted on the PCB of a real application in a real life. If during the testing just one part of the sample fails, then we test the whole lot. This is just an example of data sheets taken from the markets. Please have a look at the statement, which is down below. It's written on the truth. You can see this correctly. I will read it out loud. All limits at temperature extremes are guaranteed via correlation using standard statistical quality control, SQC in brackets. Doesn't it sound dangerous to rely on statistical calculation while the aircraft is exposed to extreme low temperatures, or a gas pipe in the middle of the desert, which is extreme high temperatures? The only solution, according to our policy, is to test the elements of the system in advance under conditions they will be exposed to during years of operation. Let's have a short look on our documentation. I just have taken a well-known silent switcher, LP8614, just to show you how we run with the testing. There are two types of products available, which differ from each other with a temp range. The first one, here in the bottom, is described as E, meaning extended temperature range. The second one is rated I, industrial, but you can see on the right-hand side that the temperature range is exactly the same. The difference between E and I comes from testing. When you take a look at electrical characteristics table inside the data sheet, you can see some dots, some red dots, along along with some parameters. This red dot means that this particular parameter was tested over the full temp range of the product which is rated to. For example, if we are speaking about this particular one, and the I grade is tested at minus 40 degrees centigrade and plus 125 degrees centigrade. When your product is being manufactured for many years, you don't have to worry about obsolescence of linear technology components. As we supply usually to long product life markets, this requires that our products are in production for many years in order to assure continuous supply. It is possible thanks to so-called non-obsolescence policy, meaning as a general assumption, we do not obsolete products. Once the product is released, it should remain in our offering forever, with some minor exceptions. In addition, we keep pricing on a reasonable level and keep supply for those ones who require longevity of their end product. Consider a need of costly and time-consuming third-party certification. A component obsolescence might mean months of unplanned development and additional costs for recertification in the slide. Fortunately, with linear technology, it's not the case. Our product selection guide, issued every 6 months, gets simply thicker and thicker. This is how we understand our support at every stage of your product's life. Okay, now let's take a closer look to the products that this presentation touches. I mean, micro-module products. A micro-module can be a step-down converter, a booster, isolated regulator, battery charger, or an LED driver. They can feature some additional functionality like low noise operation, a possibility to parallel the outputs, synchronization of several micromodules, conformity to EMI standard, and so forth. Sorry for that, my presentation stopped for a while. I will try to open it. Okay. Let's have a look at the traditional power products. The linear regulator is simple to design. It features low noise and few components, but at the same time is limited by input to output ratio and power transfers. With monolithic switch mode regulators, we require more components around. Layout must be drawn carefully, but this solution is more efficient. As MOSFETs in switching modes controller regulator design are external, it can provide power dependable on MOSFET choice, but it requires higher component counts, even more complex layout, with more components to be placed on the PCB. A micro-module regulator design combines good features of all three power conventional approaches: high power, high efficiency, low component counts, and simplicity. For example, a DC-DC micro-module regulator provides the efficiency of a switching regulator, and it is easy to design as a linear regulator. So what it is, micro-module power product? It is an encapsulated part containing a DC-DC regulator, power elements, MOSFETs, magnetics, choke or transformer, some passives, and the heatsink, all in a compact molded plastic package. Let's put the available solutions into a graph, having design or layout efforts, power level, component count, and time to market on the vertical axis, with higher values at the bottom and lower values at the top. Switch mode controller solution can deliver a lot of power, but its design is complex and long. A monolithic design is faster but provides limitation in power level. The micro-module regulator is easy to use, but not only, they provide extremely high output current in a small solution. For example, LPM 4620 delivers 26 amps in a 15 by 15 millimeter LGA package. A group of 4 LPM 4620 together deliver up to 100 amps. Let me introduce one of our colleagues, Eddie Beville, design manager of power micro Okay, everybody. I am going backwards to my presentation.
I'm sorry, I just interrupt for a second. I would like to apologize for interruption, but there was some electricity breakdown, so now we can fluently continue with the presentation.
I hope the film was visible.
Yes, we could see it and we could hear it.
Okay, perfect. I'm sorry for this situation. Sometimes you are just exposed to no electricity in the building, and well, the computer can run out of the battery, but internet needs some power. Okay. So we were speaking about the LTM4620, which is 16 volts on the input, dual 13 amps, or single 26 amp step-down micro-module regulator. The target applications for this particular one is wherever we do not have too much space, we require high currents, and we have to take care of thermal rise. You can see a couple of examples down. This means you can install it in the base stations, switches, storage and server farms, which consume a lot of energy, and also industrial processes or the control equipment. Micromodules are DC-DC systems in a package, protected by a plastic mold against outside influences such as touch, scratch, chemicals, etc. Micromodule regulators are built using newer technology silicon, the DC-DC regulator, and MOSFETs. As a result, we have full control of production, testing of the regulator IC and the MOSFETs, so that we can offer the best performance for a particular micromodule. We use shielded inductors, and great care is given to the layout of the substrate to minimize radiated and conducted noise. Also, special attention has been paid to the layouts and grounding to maximize regulator stability under a wide variety of conditions. We speak about reliability. We put our micromodules under a number of tests. The results are published. You can find this data in our webpage. At the end, I will make a live demonstration to show you where to look for this information. Okay, let's stick to the product families by its function. And let's start from the isolated stuff. Isolated micromodules contain 5 parts, 3 of them with the isolation voltage up to 3 kilovolts DC, and 2 with the isolation of 725 volts. You can see the creepage and clearance in the package, which is pretty well visible here. 2 of them have got 2 outputs with the second low noise LDO. Let's consider one of the examples. LTM8046 is a 3 kilovolts DC isolated micromodule with a total output power of 2.5 watts. The input range, the voltage range is up to 31 volts, and the whole micromodule is a tiny device, 9 by 15 by almost 5 millimeters VGA package. LTM8057 or 8058, this is another example, a slightly bigger one with 1.5 watts total output power, but with 2 outputs, for example 2.5 to 12 amps and 1.2 to 12 volts. In terms of the applications of these particular ones, you can apply these isolated modules to make buildings more cost-efficient to operate and be environmentally friendly. You can power the sensors and mixed signal circuits to measure lighting, water flow, airflow, fan speeds, temperature, which need isolation from the main network. Long power and ground wires could otherwise cause distortional measurement due to voltage drop and noise coupling. The building's infrastructure may respond as a result incorrectly. Other buildings, like industrial buildings, may need accurate monitoring and control to stay within environmental emission limits, or may have pre-negotiated contracts with utilities to limit their power consumption at certain points. Another family, these are battery chargers. Within battery chargers, we can recognize 4 parts for lithium-ion or lithium polymer batteries, which are especially prepared to take care of the lithium batteries. As you can see from the technical specification, the battery float voltage could be 4.1 or 4.2 or 8.2 or 8.4 volts. This means that we can run charging of 1 cell or 2 cells. Every micromodule charger contains a possibility to stop charging process when the charging current reaches C divided by 10 factor, or with usage of the timer. The other 2 in the next table are multi-chemistry chargers, which can run different battery float voltage, which can be set by very simple passive components. This one can be also used to charge a battery with all available power, yet maintain the input DC supply rail at nominal voltage, avoiding a system brownout or power failure. LTM-8062, on the other hand, has got the possibility to run the maximum peak power tracking, which allows us to connect it to a solar panel. In the family of step-down regulators, there are many more of them. I will go through just a couple of them. The voltage range between 5 volts and 16 volts, and just one output. You can see that the current on the outputs is really high, 10 or even 15 amps, depending on the type of the micromodule. We have also multi-output ones within the same range of the input voltage. And let's consider the last one in the table with 4 outputs. This is called LTM-4644. It runs up to 14 volts on the inputs, and each of 4 outputs can deliver 4 amps. This is why the LTM-4644 is suitable for 5 volts and 20 volts input rails and offers excellent output accuracy over temperature to meet the needs of state-of-art logic devices. 4 channels have fully independent inputs, outputs, enable, and power good pins, However, to support current sharing, all four do operate from the same block, 90 degrees out of phase, which also reduces output ripple. It can be configured as 4 output devices, each supporting 4 amps, or configured as 3 output devices, which 2 of the output current share, or configured as a dual output device, 8 amp and 8 amp, or 4 amp and 12 amp, or as a single output with 16 amps on the output. Let's have a look at the video, which is showing the efficiency and thermal performance of this flat output LTM4644 micromodule. Okay, let's come back to the presentation. Mm. In terms of applications, logic processors and image sensors often need more than 2 power rails. So for design team, decided to combine 4 rails into one solution for applications where smaller solution size, and in some cases the resulting weight reduction is highly valuable. For example, in the aircraft. In thermal derating, if thermal derating is of any concern, I encourage you to follow the analysis procedure described for the maximum operating ambient temperature section of the data sheet of this in 4644. You can see that the number of applications that this particular micromodule can be applied is numerous. Okay, let's switch to a little bit higher voltage of step-down micromodule offering between 20 and 28 volts. You can see a lot of them with pretty high output currents up to 20 amps. We have also a couple of them with multi-outputs and single outputs with the input voltage above 36 volts. Let's consider one of them, the LTM 80. This has the input voltage range between 3.6 to 58 volts and up to 2 amps output current. This could be parallelable up to 8 amps, so this means you can put in parallel 4 devices. You can also synchronize it externally between 250 kilohertz to 2 megahertz. On the buck-boost family of micromodules, the choke is external because it is dependable on our inputs and output voltages, and also the current, which is flowing through. We should consider the saturation of the stroke and should be able to make sure that the one we have chosen is the right one. We have also the drivers in the family. You can see the current outputs to drive a number of LEDs with, in this case, 1 amp in the output. Also possible. Okay. Let's consider the different product families by feature. As I mentioned at the beginning of the presentation about micromodules, some of them are low noise, some of them can be parallels, synchronizable, some of them can be recognized as conforming to EN 55/022 Class B standards. The one I would like to show you is special because of its possibility to negotiate the outputs the digital way through the serial interface on the input. The micromodule is called LTM4676. It's a new micromodule in our offering, and it gives us the possibility to regulate the output according to some commands from microcontroller or from the operator. Obviously, in the applications like data centers, the power consumption plays a very important role, and you may have a need to decrease the power when it is not needed. And this can be easily done with this one. From the power standpoint, this is a dual 30 amp or single 26 amp micromodule. regulator. If you search for it in our web page, you can find a very interesting demo board available, which is one LTM4676 and three LTM4630 with current sharing up to 130 amps on the output. You can play with that through this PM bus to USB dongle, BC16138. When running LT Power Play software, easy downloadable from our webpage. You can give comments to provide the output as you wish. Okay, we have also low output noise micro-module regulators. Let's have a short look at the demonstration of the LTM8028 and its stability of the output voltage against a deviation of the output current from 0 to 5 amps. The demonstration shows also the precision of output voltage at harsh temperature conditions. Finally, it discusses a low output voltage voltage. So now I will try to run the third video. Right. We are coming back to the presentation. One of the things which come to my mind at the moment is we are showing you some information about the testing of the demo boards. The demo boards are treated in linear technology as a tool. Miriama told at the very beginning that one of you that will send us the survey after this webinar will be able to receive one demo board free of charge. But as we have hundreds of demo boards, we don't know what you really require. So my proposal is that the winner gets in contact with myself and provides us information on what is required in the application he or she is working on at the moment. And we will make a proposal on the micro module and organize free demo boards for the winner. Okay. We have tested our micro modules at the third party, and the documentation of it is posted on our web page. You can easily find it there. Micro modules are also used by our business partners. Here you can see the Altera and Xilinx demo boards, which show our micro modules in their reference designs. Okay, now I am going to show you live a couple of points on our web page, which can be useful for your daily work. So I will share my internet browser now. Should be visible now. Let's consider we go for the LTM 4644. It's enough to put just the number. The system will recognize the right part. If you remember, this is a quad DC-DC micro module regulator with configurable 4 amp output area. So you can see a couple of features at the very beginning. You can see also the typical application with 4 outputs. On the right-hand side, you have direct access to its datasheet and reliability data. Also, you can click on the LTSpice model and immediately go into the simulation program LTSpice. And at that moment, I would like to recommend to use LTSpice. This is a program which is free to download and which helps a lot with your design work. You can see the model. It is not only the IC, the micro module, but also it contains some resistors, some capacitors, also the source of the energy. This provides you the possibility to run the application, run the simulation straight ahead. Let's try. And what I'm going to see right now is to check for the input voltage and the output currents through the loads. This is the first one, second, the third, and the fourth. You can see we are already at the 15 microseconds from the very beginning, and this way you can easily see what is happening under these conditions. Okay. On the left-hand side of the web page, you can see the section which is called the demo boards. Here we've got one demo board, DC1900A, which contains one 4644 micro module, and on the right hand side you can have its manual, the schematic, the LT-SPICE model, and also there is one which is very important from your design standpoint. This is called design file. This is a zipped file. You have to download it to your hard disk, and while opened, it contains the full documentation of this particular demo board. We encourage you to use this documentation as you like. It's free of charge, and we recommend to use it because our demo boards are created in a way that the design is perfectly done. And if you find similarities to your application, you can actually use this design straight ahead in your application. This file contains not only the schematic of the demo board, but also the bill of material, so you can exactly know what components we use to build the demo board. You don't need to search for them. And the most important fact is that it contains the layouts in PDFs, for example. You can see how it was done, every layer, and you can simply copy and paste. Under videos, you can find testing material which was prepared in our lab in California, which shows the performance of the micro module, and access to this video is also available in some of our data sheets. I will try to run the data sheet of 4620, which was on the first video presented today. Let's have a look. We'll go to the data sheet. This is a PDF, and scroll down. It takes a while. Okay, here you've got the address directly to the videos, which are related to this particular micro module on the web page. So it's pretty easy to navigate and to see what is required in this case. If you have any problem to localize the information about any kind of linear technology product on the web page, please turn to us and just send a message. We will reply to show you where to find it. And if this is not available, we can find it in our internal database and show it. Okay. Now, I am going to share again the presentation. A couple of slides more. A micro module is a set of components attached to a substrate and molded and tested like a standard semiconductor product. This we know. The comparison between the discrete power supply design and the micro module is shown on this slide, you can see the differences. The input voltage and outputs are exactly the same, 12 volts in and 4 outputs, 4 amps each. You can see that the component size and the component count is completely different. We've got 60 components on the left-hand side and just one component on the right-hand side. If you look into the pricing, probably if you summarize all the prices of the 60 components, you will get a number, and the micro module will be still a little bit more expensive. But you have to consider what is behind. When designing a discrete power supply, you need time, you need many components, you need time for testing, you need also the efforts on the purchasing side. With the linear micro module technology, we just put one components and the task is done. We call it just one afternoon course. Building a discrete power supply has a lot of extra cost in design, production, and end of life as well. Take into consideration what happens if just one of these 60 components is going end of life, and you have to change your design. In the design cost, we have to consider the Pcb cost. If the Pcb is big, then the housing of your application will be bigger. This means that the housing will be more costly. The time to market is limited somehow to your R&D time. The R&D cost is usually very high part of the cost of the whole application. And also, your R&D staff have a focus on the core competencies of them. While production is running, the insertion cost might be little, just 1 cent to 5 cents, but you need special equipment, additional wheels, and just to put in place, just to install into the put in place machine, and 40 more parts to order and to run the inventory and qualification. The test is again additional cost, and finally the less reliability. As linear technology runs no end-of-life policy, this will be not the case that something goes wrong when the end of life comes into existence. So it's actually up to you what you decide. But according to our experience on the market, with low volume, when R&D and manufacturing costs are high per unit, with high cost of PCB, for example, with an FPGA or complicated microcontroller or processor, it's really worth to take into consideration the micro module offering. You've got to decrease your R&D efforts, and your time to market is much faster, especially for the applications where time to market is critical for your commercial success with your product. With a dedicated power supply engineer in your staff, then it might look a little bit different. Or if you do only power supplies, then of course we encourage you to use equally the discrete power supply possibility. Okay. I prepared 5 more slides. I hope we can run very quickly with them, because the micro-module technology is applied also to our interface products. Just to show you very quickly how it is built. So the isolator technology contains coupled signal inductors inside, some transformer just to isolate the input and output, some power elements, some diodes, and the application die is applicable. And for example, we have the LTM2831, which is a complete isolated RS485-422 micro-module transceiver, which contains 1 watt of power, which is isolated, 1 volt. This means that you can get rid of many components on your board, having very reliable and silent micro-module with RS485. And in addition, it contains remotely selectable 120 ohm termination resistor, which is here. The same with RS232. The same with SPI or I2C micro-module isolator. By the way, the isolator barrier is 2.5 kilovolts RMS, so that's a lot. And just recently, we introduced to the markets the isolated USB transceiver, 2.5 speed, with the same isolation, with 2.5 watts output power, which is isolated. Okay, that's it for now. Here you can have the contacts to myself and to my application engineer, Joachim, who is sitting next to me. And thank you very much for your attention this morning, and once again apologize for the disruption of the power supply. Thank you very much. I think we can turn to question and answer section.
Okay, so one more time, thank you also so much for your presentation. So far, I don't see any questions from our attendees, but for sure, if there is also any question after this webinar, feel free to write to us or directly to Tomasz, and if you will write to us, we will forward this question. I would like to also thank you, all you for your time to join our webinar. And also one more time, I would like to ask you if you have a couple more minutes to fulfill the short survey at the end of this webinar. And one of you can win already mentioned demo board. According to your needs and your project. So as we don't have any question, I would like to thank you for your time, for your attention. Oh, actually, we have one question. So I want to make PSU regulation 0 to 30B. And 0 to 5 with current limit. Which integrate I/O or module you can recommend? Tomasz, can you hear?
Thank you very much for the question. Yes, can we be a little bit more precise? Regulated from 0 to 30 volts. Unfortunately, with 0 we cannot do anything. What is the input range starting from, let's say, some voltage at least?
Okay, so it's more specified 0 to 40 input voltage.
The maximum voltage is 30 volts, and we've got 0 to 5 watts 0 to 5 amps or 0 to 5 watts? Maybe you can precisely give us some more information.
It was written down amps. It's 0 to 30 volts and 0 to 5 amps.
0 to 5 amp. Okay. We do not have. That's actually the Joachim is searching at the moment for the right chart.
Module is from 0 volts. So the minimum is about 0.8 or 1.
So let's consider this is 1 volt. We will try to give you at least one solution. Normally, how we do it with our customers is when we receive such kind of question, we try to reply as fast as possible with a particular part number. But sometimes we need some more information because the number of part numbers which we can propose is simply too big. We need to narrow the selection, and usually after 2 or 3 iterations like that, we can really go 2 ways. Either we surrender and say we do not have anything in our offer like that, or we can propose something.
Okay, thank you. So
one of the proposals could be LTM 8026. That's the micro module which can yeah, the output is adjusted between 1.2 volts and 24 volts. On the input, however, we have between 6 volts and 36 volts, and the output is 5 amps. So I will repeat LTM 8026.
okay, thank you.
Mm-hmm.
So next question is, can we make 12 volts to 24 volt 6A converter with LTM 8001?
Mm-hmm. Just a second. I will open the data sheet. So the question was if we can get
if we can make a 12 to 24 volt 6A converter with LTM 8001.
mm-hmm. But this one is not the back boost. This is step down converter. So the answer is no, you cannot, because it's it takes the voltage and step downs on the output. So we should look for a micro module which has a possibility to boost the voltage. This means going from the lower voltage to higher voltage. And in this case, it could be 4607, LTM 4607, for example. But as we do not know the details of the design, we have to look further to the specification.
Okay, may I continue with the next question?
Yes, sure.
Okay, the next question is, please, can you recommend a part with plus minus 12 volt and plus 5 volt output with very fast response and long noise, indeed to use with impulse load?
So the question was for the part which is plus minus 15 volts, low noise. I can imagine that this is to power some kind of signal conditioning part with probably an op-amp, which requires plus and minus.
Hello?
Just a second, we are searching. Can we take this offline, because there are a little bit more questions from our side. I cannot see this question in written form, but maybe the originator can send us an email with the specification, and then we will take it and try to reply.
Okay. So, Mr. Lipowski, I will give you a contact for Tomasz, and can you please rewrite your question to his email for further discussion and more information. Also, Mr. Lipowski wrote me that the load is maximum of 1A. So, but still, it's better to discuss via email?
That's right.
Okay. Okay, so Mr. Lipowski, your question will be answered by email. I give you a contact for Tomasz.
I can see the questions right now. Yeah, so the best thing is really to take this kind of product selection questions offline. Because we do not want to bore the other participants on the line.
Okay. So so far there is no more question. So I would like to thank you for your presentation, Tomasz. One more time, thank all of you for your attention and for your time. I would be glad if we will see or hear each other at our next webinars, which we are planning also at the end of October and then in November. So one more time, thank you very much, and let me wish you have a nice day. Bye-bye.
Thank you very much. All the best. Bye-bye.